Welcome! In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using the PowerBasic Windows compiler. Today, we will look to produce an enhanced message box function in a dynamic linked library or a static linked library. In Windows, the standard message box can be very useful. It gives you a mechanism by which you can prompt the user to respond, all done in a single line of code. However, there are some limitations to the message box command. Within the body of the message box, you can only show text. There are also limited options for the buttons. You can only have 3, and the text on the buttons is pre-selected for you. PowerBasic's Windows help file does give you a list of what options you can use with the message box. You can use it either as a statement or as a function. The idea behind the function is for you to prompt the user to click one of the buttons and it will return the value the user has actually selected. So in this example, we are prompting the user if they wish to delete a record or not. And we're giving them 2 buttons, a yes and a no. So the purpose of this project is to produce something similar in use to the message box, but with enhanced facilities. We want to have more than 3 buttons on our message box. We want to be able to control the text that appears on each button, and we want in the area where the text normally goes to prompt the user to have not only text, but the possibility of a URL, something that the user can click on to go to a website. And further than this, we're going to create this code first of all in a dynamic linked library, and then later into a static linked library, which you can just link in with your code in any application that needs this functionality. Now that we have a rough idea of what our project is going to comprise of, we're going to create a PowerBasic Windows program which is going to be used as the test framework for our project. We have a very straightforward and small program here whose sole inclusion is the Windows 32 API. We're going to be initially accessing our PB message box from a DLL. So we'll have to do a declare statement within our testbed here to actually access that function. So we're going to call the function within this application PB message box. We're going to be importing that function from a DLL. And that DLL we're going to be calling pbutils.dll. When you're pulling a function in from such a library, you need to actually specify what the alias is. This is the name of the function within the library itself. pbMessageBox is the name of the function we're going to be referring to within this application we have on the screen at the moment. The name of the function in the library can be something completely different. But in this case, we're keeping the function names exactly the same. Our new PB message box is effectively going to be a form. So we're going to have to pass some information from our application here to the function within the DLL in order to get this form to appear on the screen. The first thing we will pass is a handle to the payment dialog. We would normally expect within a PowerBasic Windows application for it to be a dialog on screen. And once the user does something, we're going to throw up this message box. So we'll pass our first parameter as being the handle of that payment form. Next, we'll want a title for our message box. Having got those out of the way, we'll need to now pass the details of the text message that's to appear in the middle of our form. We'll want, when we create this function, for the message text that appears to have the possibility of appearing on more than one line. So this may well have embedded carriage return line feeds. The next parameter that needs to be provided will give us a list of the names of the buttons and the order they're to appear. So we're going to handle this as a delimited string. Message boxes normally have an icon showing, so we'll want an option to show an icon on the dialog. As this message box is entirely under our control, we can have as many or as few icons as are required. Our final parameter is going to pass details of which of the buttons that we have specified is to be the default button. This will be the button that will be clicked and returned if the user just hits the enter button. And the return from this function will be a string. This string will contain the text that appears on the button that the user has clicked, so this can be quite easily tested within the calling application. To indicate which icon the PB message box is to use, we're going to be passing a constant. We'll be defining these constants in here by using an enumeration. We are initially only going to support 4 icons: the critical, the information, the question, and the exclamation. But again, as we have full control over this PB message box, we can add as many additional icons as are needed. So if we simulate in here, inside our PB main function, how we would call one of these message boxes. So we're declaring a local variable called reply. This is a variable that's going to hold the return from our function. We're passing a 0 as the first parameter, as there is no dialog in this application, therefore we're passing 0 to indicate that the parent is the desktop. The title is going to be make a decision. The message text within the dialog is going to be are you sure you want to do this? And we're giving the user a choice of 4 options: yes, no, maybe, and sometimes. These are delimited by a pipe character. So what we will want the function within our DLL to do is to display 4 buttons on the screen, each of them with this as the text on the button. And we're going to tell it that we want to use the information icon and we want the default to be button number 1, in this case the yes button. So now that we have our test framework set up, we need now to code the DLL. So we will pick a DLL framework. I supplied 4 icons, named icon 1, 2, 3 and 4. These are for the critical, information, question and exclamation icons that will appear on the dialog. We're going to put these into the DLL just by using the resource icon command. The options we're using here are to name each of these resources with a name which matches its function. So PB critical, information, question and exclamation. And the final parameter is the name of the icon, which is stored in the same folder as our basic file. So we are also in the DLL creating this enumeration. This will define each of the constants to indicate which icon the user wishes to be shown. And we will set up some globals which we may add to later to define some aspects of the dialog that's to appear on the screen as a PB message box. This dialog will be quite dynamic in size, as it will depend on how much text and how many buttons the user has requested to appear. So now we need to create the PB message box function itself. This takes the parameters we'd set up earlier: the handle for the parent dialog, the title to appear in the dialog, the message for the body of the dialog, the string containing the definition of the buttons, the pointer for the icon, and the default button if the user just presses the enter key. So to give a little bit of documentation, we'll put a few comments in here to indicate this information. Now we need to go through the process of actually displaying the form on the screen. We'll have to put some error trapping in here to make sure if nothing is actually passed through, then we can just exit the function straight away. So we're going to need some local variables to keep track of everything that's going to be happening. There will be quite a lot happening, therefore we've created quite a number of variables, but we'll cover them as we come to them. So our error handling first of all will test to make sure that the user has actually passed us a list of buttons. If there are no buttons, there's no point in continuing. So if the button string list is effectively empty, then we will exit the application and return a 0 string. We can now count how many buttons the user has actually passed in the buttons variable. So having picked up the number of buttons, we're also testing the default button that the user has actually asked for. If the defined default button is actually larger than the total number of buttons supplied, or if the default button is effectively negative, we will exit straight away. Now that we've got past that stage, we can now work out where the buttons are to appear on the form. So we're defining their X and Y coordinates on the form, we're defining the button height and the button width. Having this information in here will allow you to enlarge or reduce the size of your buttons depending on how you wish them to appear. We're also setting the minimum height of the dialog and the button separation, the area between each of the buttons, and the maximum number of characters per line in the message. This will allow us to fold it to the line below. As at design time we have no idea of the parameters the user is going to pass us, we have to do some calculations to work out the initial height of our label control that's going to contain this message text, and then look to see if there's any embedded carriage return line feeds in the code and expand the text box accordingly. Now that we have that in place, and we know how many buttons there are, we can now work out how big the form is actually going to be. So if the number of buttons defined is greater than 3, we now need to recalculate the size of the dialog to take account of the extra space needed. If it's going to be purely 3 buttons, which is the minimum width, we can set the dialog width accordingly. And we will also need to recenter the buttons on the dialog just for aesthetics. Now if the title of the message box is too wide to be displayed, then we'll need to expand the dialog width to handle it, within reason. Now as you will see from this code, we're calling a subroutine called recenter buttons. Now we haven't created that yet, but we'll create that in a moment. Now that we have all the information to build a dialog, we can now go ahead and do a dialog new command to generate the dialog. As this dialog is designed to simulate a message box, we would want the message box appearing modally and also topmost. That way the user can't do anything until they actually click one of the buttons, and it will appear on top of every other window on the system. Now we can actually populate the label, the message the user has actually passed in. In order to know where the buttons are actually going to appear, we need now to look to see how big this label is, how tall is it. So we can use the control-get-size command to determine that. We are basically creating a dynamic dialog here that is sized and positioned based on the data that's been passed in. So now we know how much space the text takes up, we can actually set the starting Y position of the buttons, and then resize the dialog to accommodate that. So now we're ready to start drawing the buttons. We next need to work out which icon the user wishes to be shown on the screen, and add that as an image control. We can do that quite easily by using selectCase, based on the long icon variable which the user has passed in when they called the function. And we're using our constants to determine which of these the user has picked. So if they have picked the critical one, we will control add the image with pbCritical as the name of the resource. And the same for each of the other buttons. I've also added a case else to handle a default should we get an icon we're not expecting. And it will default to showing the information icon. And now the next stage is to display the buttons in a do loop. Since our buttons are held in a button name variable and it is delimited by the pipe character, we can use the parse command to work out the name of each of the buttons and then add them to the dialog. And as we go through each of these, we're adding on the style. If the button we're actually handling is the default button that's been defined, then we will add on the BS default constant to ensure that the dialog will show the button with a border around it, and when pressed it will be the default. Then we can use our control add command to add the button to the dialog. Then we can increment our button counter and move on to the next button. Once we reach the end of the loop, we have now displayed all the buttons on the screen. Because we have dynamically resized this dialog, it may not be centered on the screen. So we're going to call another function to center the window on our screen. We'll create that one again in a moment. We'll now put in a dialog set size to resize the dialog based on its contents. And if we have a default button, we're now going to set the focus to that default button and use a Control-Send command to set that up as the default push button. So now that we've finished defining the dialog itself, we can now use a dialog show command to show the dialog on screen and define the callback function, the event handler. If the user had passed in the default button as being 0, in other words there was no default, when the user presses the enter key, then no selection would have been made. So we're going to jump back to the beginning of the dialog to display the dialog again, so the user cannot exit the dialog without selecting one of the buttons. When the dialog ends, we are going to have one of two results. Either the user has pressed the enter key to pick the default, or the user will have clicked on one of the buttons. If the user clicks on one of the buttons, we're going to get back the handle of the button they have actually clicked on. If the result variable has a value greater than 1000, then the user has actually picked one of the buttons. Otherwise, they have pressed the enter key. So a small piece of code to actually determine this. We now have to pass back the button name to the user. So that's the end of the function which handles the displaying of the dialog. We now have to put in our callback function, our event handler. This one is going to be fairly straightforward. The function is going to handle events which come under the WM command. So if a button has been clicked, then we're going to pass back the control that has been clicked and then end the dialog. And that's basically it for the event handler. Now we have two subroutines and a function to actually design to finish up the work in this DLL. The first one was a piece of code to recenter the buttons on the dialog. This function doesn't actually do the recentering, but works out the coordinates that are required. This handles the scenarios of a single button or two buttons. The function we used was a function to remove all occurrences of a character from a string. This is a straightforward use of the remove $ command. And the final subroutine is one to center the window on the screen. This is calling a number of Windows API calls, first of all to get the window rectangle, then the system metrics, and finally to set the window position. So we will save this to disk as pbutils. So let's try compiling a code just to see if we've missed anything. And it compiles quite cleanly. If we have a look in our folder, we will see we now have a pbutils.dll, which is a mere 68k in size. So since that completes the construction of the first stage of a DLL, our next task is to test it using the module we prepared earlier. So we have our pbMessageBox code, and it's going to be calling the function within this DLL. We're passing it hopefully all the parameters we need. So we try running our pbMessageBox application now to see if we can call the function within the DLL. And there is our dialog on screen. We have a dialog with 4 buttons, with the yes, no, maybe and sometimes, and a piece of text saying, are you sure you want to do this? And it has indeed displayed the information icon as we asked it to. So having got that far, we'll now want to check to see if we're getting the value back for what's on the button. So to determine whether the DLL function is actually passing us back the text that's on the button that's been selected, we'll use the MessageBox command itself to do that. And if we run the application again now, and if we click the sometimes button, it brings up sometimes, so it has indeed returned the value we've actually picked. If we just hit the enter key, which should default to yes, which is our default button, it is returning yes. So what we've achieved today is we've created a DLL which will give us a message box that displays a number of buttons based on our selection and the text that we have defined. So if we set up another call to our PB message box function with something you may want to ask users at certain points in your application, we're going to ask the user, delete the record, what do you want to do with this record? And they have three options. They can delete, they can keep, or they can archive. The advantage of putting the text on the buttons itself is that there's less dubiety about what they're intending to do. If we ask the question, do you want to save this record? Using a normal message box, we would only have the yes or no. This way, the user knows exactly what's going to happen by what's on the screen. If we run that now, you will get, what do you want to do with this record? Delete, keep, or archive, and it will default to archive. So now we have a DLL which performs this limited functionality. What we're going to be doing in our next video is we're going to add an extra parameter to allow us optionally to show a URL inside the message box. However, that's it for today. Thank you for watching.